I wanted to keep it somewhat confined, that at this point, I think we feel we can move forward. We can look at our confirmatory factor analysis models. We know what the data look like. Looked at the means, the skewness, kurtosis, and so forth, looked at the scatter plots. And I just want to reaffirm it is 4 constructs. We had 3 item parcels each, and we want to see what is the structure of these 4 constructs, and then more importantly, is it a correlated structure so that these values here linking the factors are correlated, they're freely estimated, or is it better to map them as orthogonal constructs where the correlations among the factors would be set to 0, and even a third model where I'll set the factor correlations to be 1.0. And you probably already done this. I would ask, if I was in a class situation, what would that mean if I was setting the correlations among factors to all be 1.0? And it would mean that I think they're all one factor. So I think that instead of having separate 4 factors, it's literally like they're all one general factor with loadings on all these items. And we'll see whether that's a plausible model. As it turns out, one of them is clearly better, but one of them is somewhat plausible, not really quite, and one of them is absolutely not plausible. And we'll see what those are. So our goal, our main focus now, because we're done with the background preliminaries, is to compare a correlated, orthogonal, and all one, and these all should be plausible models. The reason I had to throw in orthogonal is I would say 90+% of the people worldwide who do PCA and factor analysis and maybe confirmatory factor analysis assume that the factors are all orthogonal. That's what the default is on SPSS, on SAS. They assume that it's a perfectly orthogonal set of constructs, which I don't think is very realistic. It certainly isn't for here, we'll find out. Okay, so this is what we want to look at. And I have 3 pages, one for each of those different kinds of models, correlated, orthogonal, and all one. And it takes just this bit of code. So briefly, and we'll run it in a moment, but just to outline, you're going to be setting up a little cubby. You can name it whatever you want. I call it correlated model. So I'm setting up a model version that's going to have correlated factors, and I'm specifying this model for R. And I do that by attaching a name to it, my model. I could just call it model. I could call it M1, whatever I want. And then the backward arrow and the dash means throw into that little cubby called correlated model the model that I'm specifying below. It's within quotes. It can have a single quote or a double quote. I don't know why I use a double quote, but I think Yves Rossiel always says use a single. This works. And the first thing you start out with is naming your factor. Satisfaction, I just put satis F to distinguish that it's a factor. And then we have an equal sign and a tilde. That means is manifested by, what are the indicators of that factor? Then you list all the indicators separated by plus signs. I have 3 measures, satis 1 plus satis 2 plus satis 3. So those are the 3 measures that will anchor my satisfaction factor. And then I do the same for all my other factors. I name this one influence 4 for career influence, influence F for factor. And I have 3 measures, and I have an equal tilde sign to say this factor is manifested by, measured by these 3 measures. And yeah, but those, climate and respect. So I've got my 4 factors specified with each of the 3 measures separated by plus signs. And I'm thinking, is that enough? No, we still want to estimate variances. Wonderfully, LAVAAN will estimate the variances without you even asking. If you have this, it'll say you're going to have a variance for every factor and one for the error variance for every measure. It'll automatically do that. So you can always put messages to yourself in comments with a pound sign. I just put estimated variance for each of the 4 factors and the 12 measures. This is the default. I don't have to do it. It will also estimate the covariances among all your factors automatically. It's the default, but I'm going to do it explicitly here, and I'll tell you why, because I'm going to need to specify them to be 0 in the orthogonal model and specify them to be 1 in the all one model that essentially looks at a general model, general factor model. So I'm going to explicitly put them here. And this is how you'd specify it. You just say each factor is double tilde, that means is covariate with influence, and it's also covariate with respect, and it's also covariate with climate. So you can just put these all in a clump. And then influence is also covariate with respect and climate. And the respect factor is also covariate with climate. So this is the whole set of covariances. I could have just done them two at a time, satisfaction with influence, satisfaction with respect, so forth, but you can do this somewhat shortcut. All right, so those are all my variances and covariances. And this bottom part is where I'm going to, and I just slipped a page, so sorry, is where I'm fitting the model. I can name it whatever I want. I was over explicit, probably could be much shorter. I said fit of this correlated model, and I asked them, the command is sem, it's a function, and I say, which one do I want to ask for the fit? I want to do it for this thing called correlated model. So I'm putting that name here, the model that I specified right here after the parentheses, comma. And where am I going to get the data? I'm going to get it from something called CFA vars. We created that little cubby with the 12 measures, so it's right in there. I'm going to request that we use the estimated the maximum likelihood one. And then we're going to say, I want a summary of that fit. So the command is summary, open parentheses. And what we put here is I want a summary of something that I called fit, the fit correlated model. So whatever you put name here, you would put that right here. And then I'm going to ask specifically for the fit dot measures. Yeah, I want those. And so capital, all capital letters, true. I want to see a whole set of fit measures, RMSEA, chi-square, standard mean square residual, and so forth. We'll check those out. And I would like to have the standardized parameter estimates. Some people don't care to look at them. I absolutely do. I want those on my figure diagram, for heaven's sake. So standardized estimates I'm going to ask for. And I don't always attend to it, but it's sometimes good to just be aware of it. I'm doing something called MI core. So the modification indices is just something I'm going to want to see. And then I'm going to call it, put it in a cubby called MI core. And then I'm going to say mod indices, that's the command, of the model that I just created for fit. And that's this one right here. And tell me what kind of things are left over in the residuals after trying to fit this model to the data. And I really don't want to see a whole subset of them. I don't want to see the whole set of them if there's tons and tons. I only would like to see them if they're greater than 10, because you know that the chi-square critical value on 0.001 probability level is about 10 point, I think I wrote it down somewhere, 10.83. So I really don't want, I'm not going to ever change anything that's less than that. So I just asked for what are